let's have a look at this next video. Match the graphs of 10 functions, f1 to f10, with the gradient functions g1 to g10. Match them up. Okay. Let's just pick out some of the easier ones and go from there. This one here, it's got a constant positive gradient and then a constant negative gradient. So what you're going to see is when you get to the derivative, it's just going to be a horizontal line at a positive value and then a horizontal line at a negative value. So it's going to match up perfectly with that one. So that is, I can't really read the numbers. I think that's f3 of x is going to be g10 of x. And there's another one here with a constant gradient, so let's get that one out of the way. Is that f9 of x? And a constant gradient is going to match up with a gradient that never changes, just a horizontal line. So f9 matches g9 of x. Okay, well they were fairly easy. Let's see what we can come up with now. Now this is your standard sort of parabolic shape, so f1 of x. And a parabola, so the derivative is going to be a straight line. You see here it's got a negative gradient, getting less negative. At about that point there, it becomes positive and gets more positive. If we look at our gradients, here's a negative, getting less negative, so a smaller negative number, positive, getting more positive. It's going to match up with that one there. So that's f1 of 8x equals g8 of x. And it's really just going through the procedure like that. And we're going to get there. What's another nice looking one? Here's a gradient that starts pretty flat, close to zero, and then gets steeper, 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 steeper as you go. Here's a gradient that starts close to zero for negative numbers and gets steeper, steeper, steeper as you go. If you remember something special about e to the x, it's the value which the derivative is the same as the function. That looks pretty much like that. So that's an f7 and a g1. f7 of x equals g1 of x. What else have we got here? Well, I think you can get the idea of what to do. Here's one where we're going to have an asymptote and undefined. We're going to have a positive gradient getting really, really, really positive. Then suddenly it's going to be a negative gradient becoming less steep. So it's going to be a positive gradient getting really, 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 really positive. And then suddenly it's a really, really, really negative gradient before getting close to zero, but still negative. So those two are going to match up together. So that's g of 2 and f of, oh, that's 9. I wrote f9 of x before. Oh, that was f8 of x, that one. Sorry for the confusion there. f8 of x went with g9. f9 of x corresponds to, which one do we say? This one here, because it starts pretty flat and then it gets really steep really quickly, which is what's happening there. And then this is a really big negative gradient, but it gets less negative and flattens out. So a really big negative gradient gets less negative and flattens out. Is that one there. So that was g2 of x. Here we go. Let's just go for the next one. So we have a gradient of slightly negative, then it gets quite steeply negative, but then it starts to flatten out again and get back to zero. So we should be going through zero right there. So negative becomes steeper and then less steep. Then it gets to zero, then it's positive, gets steeper, and then less steep and flattens out again. So negative gets more negative, then gets to zero, positive gets more positive, then flattens out again. So that one there, f10 of x, is going to match up with g7 of x. You would have heard that bell. That's me having to start an exam now. So I'm just going to upload this one. Maybe you can finish off the last three yourself, or last four yourself. I think you'll be able to. And then I'll be back with the last video soon. Good luck with everything. Cheers.